Number 5 is saying prove the identity sine squared x minus cos x minus 1 over 1 plus cos x is prove that on our left is identical to the right hand side. That's exactly what it means. So we're going to use the most expanded side, which is the left hand side. So using the left hand side, we see that we have cos x here and cos x here and sine squared x. So we can write sine squared x in terms of cos squared x. Using this identity, we say it's sine squared x plus cos squared x is equals to 1. If we make sine squared the subject, we get 1 minus cos squared x. So 1 minus cos squared x in place of sine squared x minus cos x minus 1 over 1 plus cos x. So this 1 minus 1 will get 0. So we have minus cos squared x minus cos x over 1 plus cos x. We're going to factor out minus cos x from the numerator, and that will give us cos x plus 1 over 1 plus cos x, right? If we cross out this, we get our minus cos x, which is truly identical to the right hand side, right? And that will be it for 5 part A. Moving on to 5 part B, it says hence, meaning we're going to need this to solve this one. Solve the equation sine squared x minus cos x minus 1 over 2 plus 2 cos x is equals to a quarter for that. And if we compare these two expressions, we see that for the second one, it's the first expression divided by 2. So if we divide this by 2, it will be like multiplying it by half. So it will be sine squared x minus cos x minus 1 over 2, 1 plus cos x, and that will be 2 plus 2 cos x. So for them to get this, they divided this by 2. Meaning if we divide this by 2, we also get minus cos x over 2. Right? So for this one, we're going to write minus cos x over 2 is equals to a quarter. Right? That's why they said hence. They wanted us to realize that this is just this divided by 2. Right? So if we divide this by 2, we also divide the other side by 2. Minus cos x divided by 2 is equals to that. And for this, we say cos x is equals to 2 over 4, which is as good as half, and cos x is equals to minus half when we divide both sides by minus 1. And for us to get x, we say cos inverse of minus half, right? And if you punch this in our calculators, we get 120 degrees. But that's not the only answer. We use our cast diagram. So let me explain how this works. So I'm saying in this quadrant, all the trigonometric functions are positive, and in this it's only the sine that's positive, in this it's tan that is positive, and in this one it's cos, right? And how this works is, you see how we have cos x is equals to minus 1. So we consider this a negative cos. So we're saying, in which quadrants do we have cos being negative? Because in the first one, all trigonometric functions are positive. And in the second one, it's only the sine that's positive. In the third, it's only tan, which is positive. And in the fourth and last, it's cos that is positive. Right? So when we get something like this, cos x is equals to minus half, we consider it a negative cos. So we're saying in which quadrant do we have negative cos? Because in here it's positive and in here it's positive. So it's in these two. Is it? It's in these two. Right? So if we say arc cos half, I know we get 120 already. Right? But usually when we use cast, we have to ignore this. So you say cos half, so that it gives us 60 degrees. And the 60 degrees will be our principal value. So that's the value for this first quadrant. That will be 60. And if we want to consider these two, where we have our cos as minus, for this second quadrant, it's 180. Sorry, it's 180 minus the principal value. And for the third, it's 180 plus the principal value. And for the fourth, it's 360 minus the principal value. So first things first, we forget the sign, so we take it to be positive. Then we get a principal value, which is 60 degrees. Then we go back here, we say our cos was negative, so we're considering the second quadrant and the third. So we're going to say 180 minus the principal value, which is 60, to get 120 degrees. That's our first answer. Then for the second is 180 plus 60 degrees to get 240. Then we look to see if our answers fall into this range, and they do fall in the range, so means we're taking both of them. That's how we do it, right? So for this part, we're forgetting the sign to get the principal value, and once we get the principal value, we're saying, did we have a negative or a positive trigonometric function? If it was sine x is equals to minus a quarter, that's our minus sign. But for this case, it was cos x is equals to minus half. So that's our cos being minus. So for that, we are considering the second quadrant and the third. So you say 180 minus the principal value, we get 120. Then 180 plus the principal value, we get our 240. I hope I've made that clear. Right? And that will be it for number 5.